Hi, my name's Sabrina.
My name's Haley.
And my name is Mackenzie.
And welcome to
The Couch Potato Lab,
where we bring the science to your home. So a little teaser for today's episode is, if you think about if you've ever gone to the lake in the summer, you can go swimming. And if you go back to that exact same spot in the winter, you can go skating. Now we want to kind of get you to think about why that is and how you can do those two separate things in the different seasons. But we want to, before we get into it, we want to introduce our lovely scientists. So to my left, who do I have today?
Hi, my name is Haley. My pronouns are she and her. And my fun fact for the day is probably that my favorite type of solid is balloons. And if you look around this set, you can find some balloons here today, so I'm very excited.
Awesome. Thanks, Haley. And my name is Sabrina. I'm your host for this afternoon. My preferred pronouns are she and her. And a fun fact about me is that one time in a chemistry lab, I got to extract caffeine from tea. So we actually got to separate the caffeine from all the other things that are in tea, and we got to see it. It was very cool.
That is cool. I think that has something to do with what we're doing today.
Ooh.
So you're in luck. We're going to
Cool.
explain that a little bit too.
And our last scientist to my right.
All right, so my name is Mackenzie. My pronouns are she, her. And a fun fact about me is I was at the lake on the weekend, and the lake was indeed water. So I went swimming for a bit, and it was so windy and waving, I got to go surfing. So I brought my boogie board out there, and I went surfing.
Oh, that's
It worked
so
a little.
cool.
I fell a few times, but I'm still here today. So
I
we
love
got stories,
that.
memories to tell.
Cool. So we're talking about lakes and waters and maybe different states of matter. Is that right, Mackenzie? Is that what we're doing today?
That is right.
Awesome. So we're going to talk about maybe at the particle level what that means today.
Yeah. Before we get started, let's go to Haley and see if she has anything else she can tell us about the episode for today.
Yes, we just want to start off with acknowledging that we are on Treaty 4 land. Eyes, as well as this live stream, is on that Treaty 4 land, and it is the traditional homeland of the Nehewak, Nakawe, Nakota, Lakota, and the Dakota peoples, as well as the traditional homeland of the Métis-Michif Nation. Now, you at home might not be on Treaty 4 land. We all live on different treaties, and I encourage you all at home to research and find out what land or unceded territory that you are on today. So thank you for taking a moment to recognize that.
Thank you, Haley. And now we'll get into the particles of the episode. Mackenzie, do you have something to show us?
Yes, of course. So we've talked about states of matter a little bit on the show before, but I'm going to just give a little recap, and then we're going to go a little bit more in depth with it today. So we are states of matter experts. So there's three main states of matter. So there is solids, liquids, and gases. And we know that there's some differences from like a physical point of view, so the way they look or maybe the way they feel when we touch them, but there's actually differences in the particle level too. So particles are the teeny tiny little things that make up matter. So matter is anything that has volume and takes up space. So all the different substances that are around us, they're all made up of matter. And in these states of matter, there's particles. So let's start with gases. So gases, they're kind of a tougher state of matter because sometimes they're invisible. So all the air around us is gas. That's a state of matter. Now the particles in a gas are really far apart. There's lots of space between them. So we're going to use this cup, and it's filled with ping pong balls. Oh, bouncy. So I'm going to put in, and you can see that there's 6 that fit in here. And that's about how far. So you can see there's still quite a bit of space in this cup. And that's about how far the particles are in a gas. So pretty far apart, lots of space between them. So although the balls are a solid, we're just going to pretend this is a gas. So the particles in a gas, we're going to use that to represent it. Now in a liquid, they get a little bit closer together. So liquids have particles that are a little closer than gas. So we're going to use this cup of rocks. So there's still a little bit of space in between here. They're closer together than the ping pong balls, but they're a little bit farther apart than the solids. So we're going to use that to represent the particles in our liquid. Now in our solids, they're really, really close together. They're very tightly packed. So I have a cup of sand here, and it's really tightly packed together. So there's tiny little particles of sand, but there's hardly any space between them. So just to show you very visually how much space there is between these particles, we're going to try to dump water in them. So I'm going to fill all of these cups up with water to the very, very brim. And then we're going to measure in these beakers here how much water fits in each between the particles. So let's start with our solid. We'll go the opposite way. So I've got my beaker ready. I'm going to fill it up to the top, the very tip top. And then I'm just going to slowly pour out just the water. So the actual sand is going to stay in there, so the particles will stay in there. We're just measuring how much is in between. So not very much of it drizzled down because there's barely any space. So that's how much we have in our solid. Now let's test our rocks. I got another beaker here. So I'm going to pour it in up to the brim. Perfect. And now I'm just going to funnel that out again. Make sure the rocks stay in there. Oops. A couple rocks fell out. That's all right. So already you can see that there was more water in between the particles in the liquid because there was more space. So we have solid, liquid. Now let's test our gas. Now this one's tricky because the ping pong balls float, so I'm just going to hold them down. There we go, all the way to the top. And now I'm going to funnel it out into our beaker. There we go. All right, and let's put it beside. All right, so even more than the liquid. So you can see it's just a little bit more, and then more. So it's kind of, that has to do with the space between the particles. So that's another way we can check what state of matter it is in. So scientists will use microscopes and stuff to check out the particles. And as you can see, there's more space in between gas particles than there is liquid particles, than there is solid particles. So it works on kind of like a slope, as you can see in this visual here.
Awesome. That's great, Mackenzie. I was kind of, when you were explaining that, I was kind of looking like at this balloon and how there's gas and solids in it, but like it's not really squeezing into this container, if you know what I mean. Like I'm thinking about when you pour a glass of water, and when you pour a glass of water, it all just kind of fits nicely in that glass until you take a drink. But a solid, like I would have to squeeze this, and I might pop it, to get that to fit in. So I think that we could maybe do a little test to see what the difference is between solids and liquids if you're trying to fit them in a container. What do you think, Haley? Can we try that?
I think we could, because right now I'm dressed as a solid.
Oh, your favorite solid?
My favorite solid is balloons. Ooh.
Now I have a question. When you say your favorite solid is a balloon, you mean like the outside of the balloon, right? Not what's inside the balloon.
Exactly, because what is inside is the actual balloons, or the gas themselves inside the balloon. So I'm talking about that outside, that plastic, that solid. So I'm going to try and get into that container there and see if I fit and if I can mold into it.
All right.
Sounds good.
All right.
Okay, so we're getting a solid in a container, and what happens is,
Ooh.
well, oh, you see, I lost a balloon.
Oh, man.
One's kind of sticking out over top.
Haley, can you squish down or no?
Oh, you're gonna
pop it. I'm going to pop it. No, I don't think I can.
Okay, well then, if I had to conclude, I would say a solid can't fit in containers very well.
Oh, man.
Would you say that, Mackenzie?
Yeah, so when you try to put a solid into a container, it can't change shape to fit that container. So let's imagine you're trying to put Lego inside a cup. Because it's solid, it's not going to be able to conform and change shape to fit that cup perfectly. It's going to stay its exact shape. Those particles aren't going to be able to move around. All right.
So what about a liquid, do you think? Do you think a liquid, maybe because the particles in a liquid are more spread out, maybe they can move
Yeah.
better?
So let's pretend I'm H2O, or some would say water. So I'm going to go and see if I can fit into this container.
So if we were going to dump out some water, or Mackenzie, to fit in this container, would she fit? Let's see.
So the difference between Haley and me is I'm a liquid. So I can actually change shape And I
Little
can
transformation there.
I can fit in this container, kind of.
Much
Right?
better than what Haley was doing.
Yes. So gases and liquids have the ability to change the shape for the container they're in.
So that's easy to see in liquids, but if we think about like gases like a perfume or a hairspray or I'm not sure, either two of those examples, you can't really see it, but if you do a liquid, even if you just pour a liquid into a water cup and then try and put a solid in there, it's very easy to see that one will change its shape and one will not. Very cool.
Yeah.
So we decided if solids and liquids can form to their shape. We also want to look around our room and see what in front of us might be solids or liquids or gases now that we know more about it. Mackenzie, do you have anything on your desk that might be, let's do solid first.
Solid. Well, what do I have here? Well, I could use this this ping pong ball. It's a solid.
Okay.
It doesn't change shape if I put it on my my desk. It stays as a ball. Yep, this is a solid. This is a solid I have on my desk.
Perfect. Haley, do you have a solid anywhere around you?
I do. I have a solid right here. I have an ice cube.
Okay, so you dumped it into that cup and it didn't
Yes.
change shape.
No, but
Okay.
I really want a liquid.
A liquid? Mackenzie, do you have a liquid?
I do have a liquid, but I think that I don't know. See, I have this pitcher of water here, but I don't want just any old liquid. I want to make a cool liquid, or as some would say, a solution. So I'm
Ooh.
actually going to make a sodium acetate solution here really quick. But first, I'm just going to grab some PPE, so personal protective equipment. So I'm going to grab my lab coat from under here, put that on.
Super important when you're working with chemicals. Make sure you always have lab coat, maybe gloves if it's necessary, glasses to protect your eyes.
Yes, that's right. I got my glasses right here. And I'm also going to add some gloves.
Must be serious.
Yep. Yeah, so I'm going to go ahead and I'm going to make this solution here. So I'll pull this out in front just so everyone can see my solution. So I'll turn this on. And I'm going to add 30 milliliters of water. So not a lot of water. So I'm going to add 30 milliliters of water here. Perfect. That's going to heat up. And then I'm going to add my digital scale here. I'm going to add 160 grams of sodium acetate.
That seems like a lot.
It is a lot.
Okay.
A lot more water, or a lot more sodium acetate than water. So I'm going to go ahead and measure this here.
And I think we're going to be talking more about why you're adding so much of that compared to water in Wednesday's episode. Is that right, Mackenzie?
That is right. Yes, we don't want to talk about it too much today because we'll spoil it for you, but it's definitely something to look forward to because it's very cool. So I'm just going to go ahead and add this. It's kind of hard in here, so I'm just going to break it up a little bit. This is good because now my water has time to heat because I'm actually making a solution that needs heat. So that's how all of this is going to turn into a liquid because as you can see here, this is a solid. So you're probably thinking, how are you making a liquid, right? So this is kind of similar to the activity we're going to be doing with you today. So here we go. I'm at 150, just a little bit more. All right. So I'm going to add that in. And while this is heating up, Haley, why don't you tell me about how you're going to make a liquid?
I would love to. So, like I said, I only have a solid. I only have an ice cube. But things can actually change states of matter if we do something to them. So I'm going to bring out my handy-dandy whiteboard here. All right. Perfect. So we have our simple changes in state. So I have an ice cube, which we would classify as a solid. And look at that. We have it right here on our board. It's a solid. And now, when we want to make it into a liquid, we have to have a process called melting. And now I'm sure you've experienced that when you're eating a popsicle stick on a hot day or something like that. It's melting down your fingers. That's exactly what our ice cube is going to be doing if we want it to go from a solid to a liquid. So if I let this ice cube sit for long enough, it would melt into a liquid. Now that's just one way that we can change states of matter. We can also reverse it by doing something called freezing. So with water, we would take that water, put it in a container, and we would put it into our freezer. So we want to freeze it. That's that concept of freezing. So it turns from a liquid all the way back to a solid. So it's kind of like a circle. It keeps on going.
Awesome. So if I remember correctly from what we were talking about earlier, when your ice cube melts, the particles will be getting farther away. Is that right?
That is correct.
Awesome. That's super cool. So we have one more state of matter to look around for. Haley, do you have a gas anywhere? Ooh, a gas.
Oh, I do. Actually, I have it in this cup right here.
Oh,
can you see it?
I can't see it.
Oh,
Are you sure it's there?
It's air.
Oh.
There's air in this cup, and that's what a gas is. It's just air.
Cool. Mackenzie, what about you?
See, this is tricky. See, I said that my ping pong ball was my solid, but I'm also going to use it as my gas.
The ping pong ball you're trying to tell me is a gas.
Yes, because if you cut this ping pong ball open, it's hollow. So inside here, there's a bunch of air. So kind of similar to like if you were blowing up a balloon, you'd be putting air in the balloon. That's the same thing with this ping pong ball. So I'm going to use this ping pong ball as my solid, but also my gas.
So Mackenzie, if there wasn't air inside that ping pong ball, what might it look like if you're saying that there's air in all of those ping pong balls, or if there's air in these balloons?
Well, I don't think it would take up as much space because air takes up space. So just kind of think about how if you blow up a balloon, you can make it teeny tiny or make it really big. So I think if there wasn't air inside that ping pong ball, it would just be flat and it wouldn't take up as much space.
Very interesting. Let us know what you think has air inside it or what kind of solid liquids and gases you can find around your home. You can text us at our number 1306-570-1013. You can always hashtag Couch Potato Lab on Twitter and find us there. Or of course, we're on all other social media platforms at Eyes Youth on YouTube, Twitter, Facebook, Instagram. So you can ask us questions, send us pictures of what you're doing if you're following along. And yeah, just let us know what's happening. We're going to get right into our activity, so make sure you have that lab manual handy to follow along with us. But I think we're basically going to be talking about the changes of states that we have already been talking about and going from solid to liquid or liquid to solid. What are we doing today, Mackenzie?
Yeah, we're going to be doing a lot of crystallization. Now, I want to be able to take off all my PPE, so before I do that, I'm just going to pour this out. So you saw me make this. This was supposed to be my liquid, but I put a little bit of water in, just a tiny bit, and a lot of that sodium acetate, but look at this.
It's like there was nothing put in there.
It is a completely clear liquid. So I want you to make sure that we think about how this is a completely clear liquid, and I don't want you to forget about that, okay? So I'm just going to leave it right here. I'm not going to touch it. I'm not going to do any funny things to it, and then we're going to maybe refer back to that later. So just make sure you remember clear liquid in that bowl.
I see it, I saw it, I'm remembering it. We're gonna all remember that for later. So what do we need for this activity? I think we need Epsom salts, water, black construction paper, and a paintbrush. Now, what is the first step that we're going to do, Mackenzie?
So yeah, similar to what I just did with that sodium acetate, we're going to make a solution. So solution is when you can't see the different parts to it. So you're not going to need PPE for this, so don't worry about that. I'm just going to go ahead and take mine off so you can see me a little better. I'll leave my lab coat on for a minute because it looks cool.
You just want to be the host today.
You're right, I do. So we're going to, in a similar way, make a solution and add a liquid and a solid together, and in the end, it's going to be a liquid. So this recipe is in your lab manual, and we're going to go ahead and make that together. So you have a couple options here. You can get an adult or a guardian, someone to help you make this on the stove because it's going to be boiling and very hot, so we need to be really careful. Or you can even make this in your microwave. So the first thing we're going to do is add half a cup of water. And I have my my burner still on, and it's going to heat it up. So I'm just going to add half a cup of water.
Ooh,
and
nice
then
and hot.
I'm going to add half a cup of Epsom salt. Now, if you don't have Epsom salt at home, that's all right. You can use like table salt. Any type of salt will generally work. But today we're going to be using Epsom salt at the Couch Potato Lab. So here we go. Measure out half a cup here.
Haley, I wonder if it's going to turn back into a liquid like the other one did. What do you think?
Will it be a liquid or will it be a solid? Because you're adding in two things, right? The liquid and the solid.
Yeah.
I don't know.
So actually, the reason we're putting this on heat is because it speeds up the reaction and it happens faster. It helps dissolve it faster because the particles start to move quicker when it's heated up. So those particles we were talking before, they move even quicker when it's heated up. So it actually is going to turn into a liquid after. So mine is just heating up here. It's going to take a minute. But Haley, I think you have something similar on your table. Is that right?
That is correct. I actually already made mine before the show even started. So I made an Epsom salt solution, and I have it right here. And I even have a paintbrush ready to go. Because what are we going to do with our Epsom salt solution, Sabrina?
Well, if I remember correctly, I think we're going to paint with them. But even though it's a solution and a liquid, then it's going to somehow turn into something that we can see on paper. Is that how that's going to work, Haley?
I think so, because right now in this bowl, I have a liquid right here. It's looking good. It's ready to go, ready to paint, just like regular old paint. So I think if we are ready, I will go ahead and start painting.
Let's see it.
Yeah, and I'm painting today on black paper just so that I can see it even better. All right. What should I paint, Sabrina?
Paint me a picture that I can hang on my wall. Or we can hang at the Couch Potato Lab after.
Oh, okay.
A picture of the couch potato. The one and only couch potato.
All right, I will try my very best. I'm using the potatoes behind Mackenzie as inspiration.
Well, I'm gonna try to paint an elephant, I think.
An elephant?
Yeah.
Ooh.
I'm gonna try to make an elephant. I'm not a great artist, but I'm gonna try my best here. Just using my imagination because I kind of forget what elephants look like. Whoops.
4 legs.
I haven't seen our
Tails.
in-studio elephant for a little while.
Me either.
Otherwise, I would know exactly what elephant looks like.
So, Mackenzie, yours is a solution now. Is that right?
That is right. This is completely clear. It looks like water, but it's actually not just water. It's a solution. You saw me add that Epsom salt in there, so it's definitely not just water. How's yours looking over there, Haley?
Oh my goodness, well, I think I'm almost done, but you can't really see it, and I'm really sad.
Aw.
Aw. It just looks like I put water on black paper.
It looks a little sparkly.
I think I know what we're missing.
What?
And I think we're missing patience because you actually have to wait for it to dry a little bit. So it's a little bit wet still, but if we wait for it to dry, something really cool is going to happen, and it's called crystallization. Now, I have one more tip for you, and I think that might help you too, Haley. So I actually made a few pictures before the show when I was making a pre-show Epsom salt solution, and I made one. You can see. It says eyes. Now, it's okay, but I made this one while my solution was still hot. So it was still pretty hot. They were still kind of dissolving. And then I waited. I used my patience. And look at how good this one turned out.
Oh, wow, but that looks nothing like mine.
It looks like white paint, Mackenzie. What is going on? Like, Haley's looks like she just put water on it, and yours looks like you just painted it white. Something is not adding up here to me.
Yeah, so I think what we need to do is we need to give it time to crystallize. Now, Haley, you're the crystallization expert, are you not?
I think that I am, yes. And we all got worksheets as well in our Couch Potato Lab handout. So I think that we'll go over crystallization first, and then we'll fill out that diagram together. So crystallization is basically the process where we have a solid and a liquid. So that would be our Epsom salt and our water. We molded them together. Another fancy word is dissolved it together so that it just created a liquid. And now that crystallization part is where the water evaporates. It leaves all the salt behind. It says, see you later. And we are just left with salt on a page. So we're going to bring out our handy dandy whiteboard yet again, and we're going to do that worksheet together. So I'm going to go ahead and bring it out. And I'm going to flip it over because we have something on the back. And we'll flip it over. Awesome. Alrighty, so this is the point in the show where you're going to want to bring out your worksheet that you got in the Couch Potato Lab lab manual, and yours will look something like this. I believe it is the 4th page of the document, and we are going to label it together. Alrighty, so let's start off. I'm going to grab a marker. We'll go with green for labeling. And so let's figure out, there's 2 kinds of shapes on this board. There are diamonds and there are circles. So we first want to find out that the diamonds are actually the Epsom salt that we put in. And the circles are water. So I'm going to go ahead and label our water. So I have one on the top. So we have water right here. And we have water right here. So as I said before, we have our Epsom salt over here. And we know that we start with this. So we're moving in this direction. We're moving clockwise. So maybe I'll put a couple arrows here just so we don't get confused. Awesome. And we added in water. And our water did some dissolving. So we're going to put that word dissolving right here. Ooh, here we go. Dissolving. And it dissolved. And it became our Epsom salt solution, which I have on my desk right here, and that Mackenzie was making earlier in our pot. So that's kind of that mixture with that water and those Epsom salts. So we have our Epsom salt solution. And you can go ahead and write it in here. Salt solution. Alrighty. And we want to keep moving in our clockwise direction. So I'm going to add some arrows. We're going to keep on moving here. Keep on going. And we actually have that evaporation process which we talked about, because we are letting it sit there, and all of that water, we can see it's kind of disappearing. It's moving out. So we are evaporating, and I will add that in here. Evaporating, or maybe just evaporate. And so that's added in here. So before we finish up, let's just do a review. We moved this way, we added water into our crystals. We dissolved the crystals. Then it became an Epsom salt solution. And last but not least, we are evaporating our water, and we have crystallization. So this process right here is our crystallization. Crystallization. Good thing I used 2 different colors here. Crystallization. And we are once again left with our Epsom salt all by itself with no water.
So Haley, we started with Epsom salts and then we get them back at the end through all these changes in states?
That is correct. It's pretty crazy how this crystallization process works.
That's awesome. And while we're on the topic, while we're still talking about this solution, I have a good question from our viewer, Jared. Thanks, Jared, for sending in this question. Are the Epsom salt solutions saturated or super saturated? Mackenzie, do you know the answer to this one?
Yes, I do. So the solution we made, it was a super saturated solution. So I don't want to tell you too much, because we actually have an episode coming up on Wednesday about super saturated solutions, but I will tell you this. I added 30 milliliters of water, which was like this teensy little bit. And then I added 160 grams of a solid. And then I mixed it together and it made a solution. And we call it super saturated because we added so much of this solid that if I would have added any more, it wouldn't have been a solution anymore. So I put the maximum amount in there that would dissolve. So we'll touch a little bit more about that. I don't want to ruin any of the surprises that we have planned for Wednesday. But you are right. It is a super saturated solution, and that helps us with the crystallization process.
Awesome. And so, Mackenzie, if I was just to dump 30 milliliters of water with all that Epsom salts, would it have been the same reaction or dissolving that took place when you heated it?
Yeah, so we definitely need that heat there. That heat is helping it become a super saturated solution. If I would have just left it off the heat, it would have been, it wouldn't have dissolved. So we definitely need that heat, and that heat helps it dissolve and become a solution.
Awesome. Very cool. We have one more question to answer. How many states of matter are there from the Hayes brothers?
Oh my goodness. Well, there's actually 4 states of matter. You might think it's just 3, but there's actually 4. So like we talked about, we have our solids, our liquids, and our gases. And that surprise 4th one is lava. Is that correct, Sabrina?
Lava,
That's pretty close.
I think that's close. Mackenzie, do you know what it is?
Yes, Haley was close. It's not lava, but it's plasma. So plasma, it's kind of, the reason we didn't say it off the top is because it's kind of like a subset of gases. So I'll talk about it a little later on in the episode, but there is technically 4 states of matter, but it's kind of like a subset. So there's like the top 3, and then one of them branches off of gases. So we'll talk about that a little bit later, but officially there are 4 states of matter.
That's very cool. I only thought there was 3, solid, liquid, gas. Guess I was wrong.
We're learning something new every single day.
Absolutely. Mackenzie, can we check on your other solution that you were making today? You wanted us to remember that it was a liquid.
Yeah, sure.
Has anything happened over there?
Yeah, I'm going to look around for it.
Rock, sand.
Rock, sand, gas.
That's a solid. That seems
no.
not like it's...
I put it right here, right?
Yeah, that's exactly where you put it.
I put it right here.
Is that the same bowl?
Yeah, it is, because I did.
Did
Yeah.
Skylar change that out on us?
No. You know what happened here? It turned into a solid. Look, I can literally...
It's like a Dairy Queen blizzard.
Yes, I should work at Dairy Queen maybe. Look at this. I can dump it upside down. It is literally a solid. I can, let's see. Oh, I'm making a mess here. Got a rock avalanche happening. I can literally knock it. It can make sound.
So how did that happen?
Yeah, so when I made this was also a super saturated solution. And this is basically a really, really large scale crystallization. So exactly what Haley just explained to us, it crystallized. So it's not just a little bit of crystallization. This whole entire bowl, I'm clumsy today, this whole entire bowl turned into a gigantic crystal. So I'm going to have a fun time trying to get this out of the bowl later, because it is a gigantic solid crystal. And that is all thanks to the wonderful crystallization process.
How are you going to reverse that change, Mackenzie? Like, is there a way to get a supersaturated solution to not be supersaturated anymore?
Well, if I were to take a guess, I would say that I can try to reverse the steps that I did before. So I think my first thought, my first hypothesis to try to get this out of the bowl will be to try to heat it up again. So I think if I try to heat this up again, it might start to dissolve again. So maybe I'll try that after the show and see if that works for me.
And at the very beginning of this episode, I was talking about lakes and how you can swim and skate on them, and maybe even different lakes at different times of the year. You can maybe swim earlier or skate earlier depending on what the water is like. Is that true, Haley?
That is true, and it all has to do with salt content. So we're going to do a little experiment here today just to explore how salt affects melting and how that kind of works in our swimming or our skating or any of that. So I have that ice cube from earlier, and it's taking a long time to melt. It is still a solid. So I brought this bowl out here, and I just have a regular old ice cube in it, and we are going to try and melt it faster than this one. And we're only going to use one ingredient, Sabrina. Do you know what it is?
I would have to say, if you're talking about salt, you're going to try and use salt, but that seems crazy to me that you're going to be able to change the melting point with salt.
Exactly. I am going to change the melting point with salt. So I'm going to take some salt from my baggie right here, and I'm going to be putting it on this ice cube because we want this one to melt faster. So I'm going to put it on there, and I'm just going to drizzle it on. I'm going to get a little more. And you can try this at home just using a regular old table salt or whatever you got. I'm going to put one more big heaping scoop full. All right, so while we wait for our ice to melt, I'll explain kind of what's going on here. So basically, salt reduces Sabrina, you'll have to help me out with this one, the melting point?
Yep, I think so.
Yes, so salt reduces the melting point of water so that our ice melts quicker. It doesn't need as cold a temperatures to melt. And that's kind of the same thought that we have when we might be putting salt or sand or salt on our snow to melt it so that we aren't slipping all over the place.
So you're telling me if I could use salts like on my slippery step, then it'll melt even if it's not at 0 degrees, because ice normally melts at 0, right?
Exactly. So it can be super duper cold. It can be minus 20 degrees, and you might be able to melt that ice on your step so that nobody hurts themselves.
Wow, that's very cool. Oh, I see it looks a little indented at the top where that salt was dumped on.
It is. I can see that it's melting way quicker. We have a lot of liquid in the bottom, that melted water. And if we compare it to this one that has no salt, this ice cube has no salt on it, it's catching up pretty quick.
I see that, and the liquid is definitely taking shape of the container, because you can see at the bottom it's like touching everywhere, where the ice cube in the one that's not melting is still just a solid hanging out in the glass.
Exactly.
Okay, so while we're waiting for that to melt, I think we should play a fun little game of Eyes Spy, where we continue to look for different solids and liquids and gases around the studio. Mackenzie, do you want to start?
Sure. We're playing I Spy or I Spy?
Eyes Spy.
Like eyes.
Like I Spy.
You're funny, Sabrina. Okay. Okay, I'll start. Let's look around. What's something really cool? Ooh, I know. Okay. I spy with my little eye something that it's sometimes a liquid, but sometimes it behaves like a solid.
What?
I see it kind of over there. It's
Is it
white.
ice?
It's not ice. Nope. Good guess, though.
But what do you mean it's sometimes a liquid and sometimes a solid?
Like when it's
Wow.
changing states?
Kind of. I think that this is a special fluid. Haley, look around your desk. I'll give you that hint.
Something around my
It's-
desk.
It's not the
It's
solution.
in a bowl.
The Epsom salt solution?
It's
that
in a
doesn't
bowl.
seem right.
If you think about a liquid, it takes shape of the bowl. So
Okay.
it's definitely taking shape of the bowl.
Okay.
But if you touch it, it behaves like a solid. So maybe try to like touch some of the solutions or the mixtures that you have on your desk.
Well, I have this bowl right here, and
Looks
if
like porridge.
yeah, it looks like porridge, and if I wiggle it around, it's definitely a liquid. Here, I'll put it back down. It's definitely a liquid. It takes shape of that bowl. But what happens if I try and touch it?
Oh, it's stuck.
Oh my gosh. It's like a solid when I touch it, but if I just kind of wiggle it around, it's a liquid. So that's
What?
kind of that solid and liquid that you were talking about there. Is this what you're eye spying?
Yes, that is what I was spying with my little eye. So what you found is oobleck. So oobleck is it's like a tricky solution or substance, and it's called a non-Newtonian fluid. So it sometimes acts like a liquid and sometimes acts like a solid, and that depends on the forces that are acting upon it. So when we like punch it or touch it, it's solid, but if we let it kind of flow just freely without putting any force on it, it is a liquid. So if you want to find out more about that, you can refer back to our episode from last week, and you can learn more about oobleck, and you can also make your own.
That's very cool. I had no idea that anything like that existed. So it's not a new state of matter. It's just both, right? Like it's both solid and liquid. It's not like its own state of matter.
Yes, that's right. So it still follows the properties of both. So I would say that if I had to classify it, I would take a guess and say it's more so a liquid, because when you put it down, if you're not putting any forces on it, it takes shape of the container, much like a
Right.
liquid, whereas it needs that force constantly acting upon it to be a solid. So unless there's like a constant force constantly pushing on it, I would probably classify it as a liquid, unless the circumstances changed and it wasn't just sitting in a bowl or something like that.
Right, that makes sense. So the particles act more like a liquid, so that's why you would classify it as a liquid. That makes sense to me. Okay, why don't we check, do you think it's been enough time for our papers to see if they've completed the crystallization process yet? How's it looking over there?
I think it's looking pretty good. I think right before that, would you mind if we checked on the ice here? that's
Sure,
melted?
let's see.
Awesome. So we have even more of it melted. I'd say we have half an ice cube sitting there compared to our other ice
Oh,
cube that's
wow.
still sitting there as a solid. So we can for sure see that the salt changed that melting point of the ice.
Can you try dumping some of the water out of the salt ice cube? Let's see
I
if it's a
can
liquid
definitely
yet.
try.
See if it takes shape of the
Oh,
of
yes.
a new container.
See if it takes shape of a new container. All right.
See if it's a liquid yet.
See if it's a liquid yet. We'll test this out. I'll put this right here, and then I'll pour our water into here.
Oh, quite a bit.
Yeah, quite a bit. And it totally took shape of this new cup, this container. It didn't just sit there like the ice cube beside it.
Because there's hardly any water in that other ice cube.
Exactly.
All right. Isn't it crazy how we use changes of matter and changes of states in our everyday life? Now I know exactly why I'm putting ice on my step when it's icy in the winter.
Exactly.
Very cool.
Great.
Okay, let's see your potato over there,
My
Haley.
potato. It's coming along. It's coming along.
Well, that seems better.
So
it still looks a little.
It still looks a little watery, but I can see how we're getting that white paint. Oh, which way am I going? White paint right here. I think it's just a little too wet at the bottom. So we would just need some more of that patience that Mackenzie was talking about that I really don't have.
Me either. I'm not that patient of a person, but I think maybe if you even leave it overnight in the morning, the results would be really great. Or even a few hours, because Mackenzie, you said you had tried those other ones earlier, right?
Yeah, I did. So another thing you could do if you don't think it's quite like the white isn't bright enough, you can actually paint once it's completely dry, and if you feel it's dry, you can paint over it twice, and then that'll kind of just like put another layer on it and make it a little bit thicker. But Haley, one thing I thought was really cool about yours, it kind of made me start thinking about why they call this crystallization, because crystals, when I think of them, I think of like really shiny things, like shiny crystals and diamonds. And when you were flickering it in the light, it was really, really sparkly and shimmery, like really crystally. Can you just hold it up for us one more time so we can admire how sparkly it is?
Of course. I'll try and
Shimmer it in the light?
Yes, shimmer it in the light.
Oh, look at that.
Oh, I love that. That's so pretty.
Yes, so I'm sure that when this dries all the way, we will have a very sparkly paper right here. Very sparkly potato.
Yeah.
Ooh.
I love that in science we can also incorporate art. So a lot of times on the Couch Potato Lab we talk about STEM, but there's also a thing called STEAM. So STEAM is an acronym that stands for science, technology, engineering, art, and math. So I love that in this crystallization there's not only just science, there's also a lot of art. So I got to show my amazing artistic abilities and my not so great elephant. But I got to show both abilities in one project. So I think that is very cool that we can do that.
I love that idea of art. I was thinking, Mackenzie, do you think you could make different colors of this solution if you used food coloring? Do you think that would work if you actually wanted to do more art with this, to have like red or purple? Do you think food coloring would work or not really?
You know what? I think it would, because I don't think it would change anything in the crystallization process, because you're just adding it to the water. So I don't think it would change anything. I think that's a really great idea. Maybe if you use like a gray paper instead of a black paper, they might show up a little bit better. I think that's really, really great. We should try that.
Yeah, we should. Or you can try it at home and let us know what happens. But we have another great question on the topic of Epsom salts. So why are Epsom salts used for baths? What does it do to our body? From the Hayes brothers. Thank you, Hayes brothers. Mackenzie, Haley, who wants to take this one?
I can start with it, and then Haley can add all that she wants to add.
Sounds great.
So Epsom salts are mainly comprised of two different ingredients, and those are magnesium and sulfate, and they're combined together in these salt crystals, and they help just remove toxins from our body and kind of like pull them out of our skin in the solution. So when you're kind of like soaking in the tub, it'll take them out. It also can sometimes help with like muscle soreness. So maybe you just went for a run, you were playing outside all day and your muscles are kind of sore. They say that it can help with muscle soreness, so maybe some inflammation. So that's when there's like extra inflammation in our body. They say that helps. So it just helps relax us and has a few positive effects to our body. So maybe if you want to have a relaxing night one night, you can try to put some Epsom salt in your bath water and see what that does.
I know I do that sometimes when you have a long day, you just want to take a nice warm bath, dump some Epsom salts in there. It just makes you feel better.
Yeah. And the great thing about science is there is always more to learn. So Epsom salts are still being studied. There's not necessarily a lot of, they're still looking for a lot of facts because we want to make sure in science, if we find something out, we want to make sure that it is 100% true and that the data and the evidence that we find supports it. So they're still looking for more evidence to find ideas that support that Epsom salt has an effect on our body if we use it. So scientists are hard at work finding more and more out every day, and that's the great thing about science is there's always more things to learn and know.
And Mackenzie, I remember you mentioning something before about a fourth state of matter. Do you want to talk about that a little bit now?
Oh, whoops. I just got so mesmerized by this thing here, and it has something to do with what we're doing. So I'm actually going to break the rules. I'm going to break the set.
Megan, hopefully
I'm
she's not
coming out
watching.
from the darkness. Going to bring this right here. And I'm going to plug it in so it has some power to it.
That to me looks like a solid. What do you think, Haley?
A solid for sure.
I don't know if it's a new state of matter, but I guess we'll see what Mackenzie has to say.
Yes, so I'm not sure if this might help. See, no, it's still pretty light here. But if you look really closely,
There we go.
there's some things going on in here, and that actually has to do with that fourth state of matter that we were talking about. So what is inside here, there we go, is gas. So there's some gas inside here, but not just any gas, there's actually plasma. So you can see that there's these little particles in here. And I just want you to look at them. They're kind of mesmerizing. Now, plasma is a state of matter, and it's, like I said before, it's often thought as a subset of gases. But the two states, they kind of behave differently, which is why it has its own state. So unlike ordinary gases, plasmas are actually made up of atoms, and some of these electrons in the atoms have been stripped away, and then they're positively charged. So if they're positively charged or negatively charged, we call them ions, and they're roaming freely in here. Now this right here is illustrating plasma, and it's called the plasma ball. So the way this works is this thing right here in the center, that's an electrode, and that electrode is emitting really high frequency. It's got different energy and different electricity coming off of it. And then this ball is filled with a gas, a plasma gas. So maybe gases like neon, things like that. And then it's making these different colors. So if you see, I'm going to actually put my hand here.
Whoa.
Can you see that it creates? And that's how you can tell that there's just electricity in here, because humans are conductive and they conduct electricity, so it's moving with my hand.
Does that hurt, Mackenzie? Like, are you getting shocked right now?
I'm not, but you do have to be careful to make sure where you're standing and stuff. I've made sure that I'm in a safe spot, but there is electricity getting emitted through my finger, but you can't feel it, which is good. So that's pretty cool. That's how a plasma ball works. And if you want to be mesmerized them more often, they're actually part of our set, which is very, very cool. So another thing that's cool about plasma is if you sometimes go to restaurants and then there's those like, really bright signs, sometimes they call them like neon signs, it's the same idea. So it's a sign filled with, there's little like rods in there, and those rods are filled usually typically with neon gas, and then the light goes through them and makes them super bright, kind of like this ball.
Very cool. I would have never guessed that that was a fourth state of matter.
Yeah, there you have it. Learning something new again.
So it's time for one of our favorite segments of the show, Ask Our Scientists. So if you have any questions, make sure you text or tweet them in, and we'll get to answering them. So we have one question. Our very first question is, can all elements of the periodic table be all three phases of matter? So can every element be a solid or a liquid or a gas?
I think I can take this one.
Haley's got this one?
Yes, so the answer, well, there's so many elements on the periodic table. So the answer is no, that not all of them can be a solid, a liquid, or a gas. And you'd probably think that a lot of them couldn't, but it's actually just one of our elements that can't be a solid, liquid, or a gas, and that is helium. helium can not be a solid.
So helium, like what's in these balloons, is that what you're talking about, Haley? Is helium?
Yeah, kind of. Helium is that you might have breathed it in once from a balloon or of some sort and had a really high-pitched voice, kind of like a chipmunk. So that's kind of what we're thinking of when we're thinking of helium. So helium cannot turn into a solid.
Very cool. So while we're waiting for more questions to come in, these 3 balloons is what we're going to be using for our final segment of today. So they're labeled A, B, C, if I could put them in the correct order. And I want each of you to pick one of these balloons, and whichever balloon is left over is what I can take. And then I'll tell you later what we're doing with them. But for now, pick a balloon of your choice. Haley, you want to pick first?
I do want to pick first. I really want to pick A because A is awesome.
A is awesome. Okay. Mackenzie, do you have a preference of which balloon you want?
Well, I don't know what we're doing with them, but I'll pick B because it's the smallest balloon, and I like small little things, so I'll go with B.
You'll go with B. Maybe B will do the less damage. Okay, so I'm left with C. I'm left with the biggest one.
All right.
So what we're going to do is I have, before the show, secretly put one state of matter in each of these balloons. So, for example, one will have a solid, one will have a liquid, and one will have a gas. And so what we're going to do is we're going to hold them over our heads and pop them. Are you two cool with that?
Wait. You could have told me that before we picked our balloons. I might have had a different choice, but honestly,
that takes away the fun.
I'm feeling pretty confident in my choice. I think
think
there's definitely air inside of mine, so I definitely have nothing to worry
I
about.
definitely think mine is full of air because it's so big, and it looks like there's lots of air in mine. That's what I think. I don't think yours has air in it.
I don't know. I'm excited to find out,
Me
though.
too. We have another question. Does ice cream crystallize? So the ice cream, if we're thinking about the ice cream that we eat, does it turn into crystals?
Yes, it does. So, it's called ice cream because the ice is crystallizing. So the milk and the sugar, all that adds together, and then it crystallizes, and that's how it becomes frozen. That's how you freeze it. So it's kind of like those state changes that Haley was talking at the beginning. So it goes from a liquid to a solid, and that's freezing. And then similarly, you can go from that from that solid back to the liquid. So if you're not eating your ice cream fast enough, it might melt. So yes, there is crystallization involved in making ice cream as well.
I think about old ice cream in my freezer. I think when it gets like freezer burnt, there's even more crystals that form on top of it. Has anybody ever seen freezer burnt ice cream before?
Yep.
Yeah.
It's
And
not too tasty.
Would that be sort of another crystallization process, do you think?
Yeah, I would say so.
With the little crystals, shiny crystals on the top?
Yeah,
Yeah.
I would definitely say so.
Awesome. Okay, another question is there a state of matter dance?
Well, I was really not wanting to bring out my secret talent. Do you think they really want it?
I think they do. I don't think they would have asked if they didn't want it.
Okay, can I teach you, Haley?
Yes, of course.
Okay,
Of course.
let's go in front of our stations. I'll teach you.
There's really a dance?
Yes, there's a dance.
Okay,
Of course
okay.
there is a dance. Okay, so we're gonna be stiff.
Okay.
This is called the solid dance. We're just gonna jump up and down. We can't change shape. Ready? 3, 2, 1, jump. Kind of like a penguin. This is our solid
Like
dance.
a pogo stick.
Yeah. Okay.
Okay.
Okay. Now, our liquid dance. We're gonna flow. We're gonna go like this.
Ooh, I like this one quite a
Yeah,
bit.
this is our liquid dance. We can flow. We can move.
Like you're surfing on the water.
Yeah.
Ooh.
Now, gases can move even more freely because those particles are farther apart. So we're gonna really flow.
Ooh,
Oh.
wow.
Yeah.
I
There you
like
have
this
it.
one.
This is it. All right.
Round of applause for our lovely
we go.
dancers.
We'll bow.
Thank you.
Curtsy. Yeah, there it is.
Mackenzie is a dancer, if you didn't know that. She loves to dance.
It is true. I love to dance, and apparently I need to do a little bit more because I'm out of breath.
That's your cardio for the day.
It's true.
Okay, let's pick these balloons. So this one was mine, right? Haley,
Yes.
because you picked A for awesome or amazing.
Both actually.
Okay, I'll set that. Can you reach that on my
Yes,
desk?
I can reach that on your
'Kay.
desk.
And I will pass this one. B for beautiful for Mackenzie, if you can
isn't
reach
that
that.
so nice? All right.
Okay, so if everybody has a pen, maybe let's do one at a time. We'll start with Haley.
Okay.
She can pop hers over her head with a pen.
Now, I didn't admit this earlier, but I'm very scared to pop balloons. I've never done it before, so bear with me.
Do you have a balloon fear like Katie does?
Not a balloon fear exactly. I guess you could say I do.
Okay. Well, thanks for doing it anyway.
Yes, I'm very excited.
Okay, so is it going to be a solid, a liquid, or a
A
gas?
solid, a liquid, or a gas? Maybe I
Ooh.
can hear it.
Do you think they sound differently?
I don't know.
Me either.
Okay, I will give it a try. 3, 2, 1. Oh, nothing.
Empty.
So
well, not
does
empty,
that mean
but
I had the gas?
must have been because there was only air in it, right? I didn't see anything pop out.
That
Okay.
was super scary.
So
Awesome.
if you had the gas, then that means I either have the solid or the liquid. Okay.
Oh, that means I either have the solid or the liquid too. I wanted gas. What happened here?
I wanted gas too, but maybe this doesn't feel too heavy, so hopefully it's just not rocks that are going to hit me in the head. Okay, here we go.
3, 2, 1.
Okay,
Oh.
that wasn't too bad.
Okay, that was a pretty nice, like, soft, solid.
Mackenzie,
Oh, wait.
do you know what this means?
Oh no!
Okay, let's go. Let's
'Kay.
go. Let's see it.
3, 2, 1.
Oh my goodness.
It was a liquid.
She got the short end of the stick for sure.
Well, okay. Well, I was pretty hot, so at least I'm cooled off now.
I hope you brought a change of clothes because I think it's kind of windy out today. You might get a little cold.